StructSure AI QA works by importing pairs of volumetric anatomy data sets and compares them quantitatively and objectively using both standard and user-defined comparison techniques to generate metrics of agreement. The metrics act as summary measures to describe the, quote, sameness between data sets. Multiple and user-defined metrics also allow clinicians to design the metrics to suit their specific needs. So basically what it does is it'll take a contouring set, okay, a structured data sets, and it'll compare one data set versus the other one based upon a common CT set. So you have this one CT set that was maybe done on a head and neck, let's say, and say, let's say recently, one of your dosimetrists did this great contouring set and said, boy, that one was really, really well done. And then you say, okay, hey, we're looking at buying this auto contouring engine. Let's run that same CT set against that, generate the structure sets, the data sets, and then load them into StructSure AI QA, and then compare the two and see how well the autoseg engine did against my gold set. That's really the kind of the emphasis behind StructSure. Slide to move. There we go. So why is AI QA important to you as a physicist? Well, first of all, it's a great tool when evaluating an autoseg engine for purchase. You know, here you are, you're thinking about buying an autoseg engine, you know, and ideally, you know, you would try to get a temporary license to, you know, try it out, you know, and excuse me, kick the tires on it. Well, StructSure AI QA is the perfect tool to organize and produce objective evidence. You know, is the Aiqa model working the best? Is the Varian model working best? Or are any other third-party companies that are popping up across the industry, you know, and doing really good work like Limbus AI or any other half dozen or so autoseg companies that are emerging? And you could, like, you know, try one against your goal set, try another against your goal set, and you can see which ones really work well for you. Again, it's kind of a, you know, you evaluate before you buy it. Number two, acceptance testing. So, you know, when you finally do buy an autoseg engine, you know, you want to go through like a whole range of acceptance testing. You know, I'm going to do it against the head and neck. I'm going to do it against, you know, a variety of different images that you want to work against. You know, certain, you know, does the autoseg engine do well with certain organs of the model, but not so well on others? You know, against, doing that comparison against your gold set. The user, you know, is going to have to. Rather, it's extremely inefficient to ask, you know, if the results are, you know, do you like them or not? You know, it's not very scientific, and it lends itself to, you know, being subjective. AI QA provides a quantitative analysis that you can rely on. So, you know, if I look at a particular autoseg engines, I go through a whole variety of data structures or structure sets, and I see that, you know, it does well on some organs and not, I can see why they're different, you know, because AI QA will provide you that, you know, quantitative analysis. So again, as I said a moment ago, you know, you would use a StructSure AI QA before you buy an autoseg engine, and then you would also use it during acceptance testing and see what areas work the best and maybe not so good on others, and know why they're different. And finally, number three, vendor updates. You know, autoseg engine updates are going to be much like DOS engine updates, you know, but much more rapid. They're gonna be changing continually and releasing updates. You know, they're like, hey, now we got, you know, version 2.5 that includes small vowel or whatever. Okay, so you know, you want to take a look at that and say, oh, okay, great. Let's see if you know, how they did on the small vowel, because I happen to have a gold set of that too, and yeah, it looks pretty good. Or what might happen, and this happens in software development, where you know, let's say they improved, you know, they added a new type of modality, or they're doing a new organs or something like that, but now for some reason head and neck is broken. You know, it doesn't work anymore. What's going on with that? And again, so it's used, you know, for, you know, vendor updates, just to make sure, you know, that you're seeing what's improved and what might have gone wrong in the transition. So why is StructSure AI QA important to the administrator? Well, first of all, you know, it ensures safety and accuracy. You know, AI deep learning auto-segmentation technologies are emerging, and they're promising. Widespread implementation is imminent. Verifying the accuracy of auto-segmentation in an objective and rigorous manner is paramount. Number two, make data-driven purchasing decisions. Using StructSure AI QA to generate accuracy data to see how well different algorithms reproduce the standard of contouring quality that you expect. Request from competing vendors to have a trial license of their auto-segmentation solutions. Select your own data sets and standards against which to compare. Then use StructSure AI QA as an objective, quote, referee to help you determine which products give you the expected output. Number three, implement an efficient and reproducible validation process. Just like you must validate and commission dose calculation engines, you will also need to validate and commission your auto-segmentation models. You will need to do this not only initially, but also as the models evolve and new models are added. StructSure AI QA process is efficient, comprehensive, and can be automated and reproduced via batch analysis. Number four, communicate better with your auto-segmentation vendors. For any body sites, models, or anatomical structures that do not pass your validation or need improvement, StructSure AI QA produces a wealth of data about the errors and differences versus expected results. These objective measures can be shared with your auto-seg vendors to ensure clear but comprehensive communication, and to avoid debates based on subjective observations. And finally, the low cost. AI has a low cost, entry cost, and can even be paid as an as-needed basis via SaaS pricing. So let's get into the actual software itself to give you kind of a quick nickel tour here. So here it is. Here's StructSure AI. It's actually a very simple application. It's a Windows desktop application, very easy to install, really nothing to it, and it's you know, no fuss, no muss. You know, it's the only thing that's you'll be given a license to use it, and that's about it. There's really nothing to it. So let's get started here. So what you'd start by doing is you'd open up, you want to load your data. So here we go with this load data dialog. And so the first thing we're going to do is select our CT sets. This is the common set of CTs that were used to create the two opposing data sets. Now, truth be told, you actually don't have to have the, oops, there we go, come on back. Have to have these files here. You take a look at the CTs. They're really just there so that you have a sense of reference of where you are, you know, with all the slices. Really, the comparison is between the two structure sets. So let's open up our primary structure set, and this is your gold standard. This is the one that was, maybe done by an autoseg engine that you, really trust, or was done by a human being some time ago that has always been kind of your gold standard. This is the one, that Margie did, about a year ago, and boy, this one nails it. So here it is. And then the secondary one is this is the one that the autoseg engine did, or quite honestly, say another human being. It doesn't really matter who or what did it. It's just that you're going to compare this against your gold set. So you go ahead and open that up, and let's just take a quick look at what we got here. So when we looked at the primary set. This is your gold standard. It said, hey, I found these things. Of course, the label, test contouring, and here are all the regions of interest that I found. In the secondary set, it says it does the same thing. Here are all the regions that I found, but by the way, here are the regions that I found that match the primary set, okay? And so here's what I found. Maybe not all of them. I found, let's say, maybe a few more than this one did, but here are the ones that were a match with the primary set. So let's go ahead and just load the data, and here we go. And you can see the screen is divided up into like 4 areas. Up here we have this navigation view, and this kind of gives us a bird's eye view of the entire set of CT slices that was provided for us. Down here are all the regions of interest. Here are the regions of interest that I mentioned a moment ago that there was agreement between. I'm going to talk a little bit more about how it recognizes these things and whatnot in a few minutes. And also, here we have this thing called a metric method. And I'll talk about that in another couple minutes, but just know that these are all user definable. You can make up your own, and these are the, I would say they're really, calling them like scoring. How you're going to score the difference between the primary and secondary set, or your gold standard versus the autoseg engine. Okay, so it's how you're going to maybe penalize, or give credit for the differences that you're going to see here. Down on the bottom here, we've got an image adjustment, basically. A window leveling type of, you've seen this many times in other kinds of software. And then, of course, here we have our main view. We're using our scroll bar, our scroll wheel here on my mouse. I can roll through the different slices just like normal. And let's say I'm going to move up to, here, this is probably a good one. And here I can see here, the different regions here. Now notice, if you can kind of tell here, maybe this is an okay one. The solid lines, that represents our primary. That's our gold standard. And then the dash line is our secondary, the one we're going to compare against, let's say an autoseg engine. And you can kind of see there's some differences here, okay? But this is just from a visual point of view. So now let's take a look at all of these regions of interest, and let's run these metrics against them. And so I'll hit the calculate button. And presso changeo, we got it done here. And we can start to see some interesting things here. And we've got 2 panes here. We got this one, and then we'll have this analysis pane here as well. But let's just go right away to the axial planes. And so what we have is everything's color coded, as you can see. And I can adjust the opacity here just to maybe give a little bit more definition for you guys. And so what we have is the green represents common. Here are the areas of agreement between the 2 data structures that, yes, we definitely have agreement here. Okay, great. Anything in blue is where as compared to the primary set, the secondary set missed. Let's say your gold standard went way out here, but your secondary did not. It did not go up there. Here's another good one right here where you can kind of see it a little better, where it's a dashed line, and it says, yeah, it just simply missed all that. Here's another one here. I'm going to just kind of roll up. Here's a better one. And then right here, we can see here that the brainstem, we have good agreement in the middle here, but on the top, right here, on the forward part, we have where the secondary, or let's say our autoseg engine, missed. But on this side, it actually thought there was something there and actually overshot and actually radiated good tissue. Here's another example right here. So, and so from just a quick visual aspect, you can kind of quickly take a look and go, oh my, look what happened here. So but let's dig down a little bit further and take a look at some metrics. Again, what we have in the top here is a table view of all the regions of interest, just right here. It matches all of these. Okay, and so let's just take a look at what we have here. So on our first one, we have, it's all broken down by these columns. And the very first one, we say, okay, the volume of volume 1, this would be our gold standard set, we see that in this particular volume, we have 172.52 cubic centimeters of agreement. And then in volume 2, we have, which is this is our gold standard. Here's our secondary one, let's say the autoseg engine. We have 172.388 areas, of agreement. So here, or rather, here's the area of agreement, 172. Let me go back. I didn't quite say that right. Here we go. First one is the volume 1. That's our gold standard. It found this much volume. And then number 2 found this much volume in cubic centimeters. And so between the two, the common was 172.388. And what was missing, rather than that blue area that I pointed out a moment ago, there was 0.132 cubic centimeters, no extra. There is, of course, a dice coefficient here, that a standard algorithm. And so what's the max difference between the two here, between the two volumes, is 1 millimeter. And then using our metric method, again, this user-definable scoring method, we say, if it's within 1 millimeter, that's great. It's this is 100%, and looking good, and we're gonna give that a green. But as we kind of walk through the rest of these, let's say right here, the right optic nerve, we start to get into the yellow a little bit. We see that it's we've got a bit of a lesser score, 61.67. Based upon our default linear algorithm here, and it's like, this is not so great. And then, of course, if we get down to this last one here, we see that it's definitely in the red. Let's take a look. And by the way, each one of these tabs here, you can see how they can flip back and forth from a user interface standpoint. But let's take a look here just for a second on what we see on the bottom here. And this is the distance volume histogram. And of course, here we have, great agreement. Everybody's right in the center here, and and there's really no error. But if we go down to this last one here, we can see lots of errors, and so, or at least there is a big difference of agreement. Let's put it that way. And as we move away from the center in a millimeters, we can see that there's in here, remember, the red represents areas where it overshot, and then the blue represents areas that it just basically missed as compared to the gold set. And so lots of great data there. On the right-hand side, it breaks it down even further, giving you all of the things that it's using to come up with these metrics. So yeah, all of that is available to you and it can be exported, and is to do more analysis with. We'll talk just a little bit more about some of our metric parameters here. This is this metric method, and so there we go. You could come up with a whole myriad of them on your own. Out of the box, you get this one, the default linear. Okay. And so basically, this is just on a linear scale. So the further we move away from, 0 here, right in the center line, I'm going to add this kind of like this slope of penalty. You know, either on the, hey, this is the missing one, or extra voxel penalty score. I can change that to whatever I feel like doing here. All of these times, again, got a few more here that are just kind of silly. But anyway, there we go. But you can do whatever you'd like to do, you know, and depending on what it is that, you know, you're trying to score on. There's lots of information on how to do this in the user manual. It's really pretty easy. I won't get into that right now and bog everybody down, but it's pretty quick and easy to do. Another thing here, yes, regions of interest rules. So, you know, when I mentioned earlier that when we first did this, we loaded the images, and as you guys know as well as I do, that, you know, one set of DICOM image, or one kind of set of DICOM data sets may not be called, you know, all the regions of interest may not be called exactly the same thing. Like you know, a left eye might be L_I, or left space I, or I left, or whatever. And then the other one is something else. Even though we're talking about the same thing, they're labeled differently. What you can do here with the application is you can create basically associations, meaning, you know, left eye can also be L_I, L space I left, etc., etc., etc. And then you can give it a default metric method if you want at that point. So again, it's a great way to be able to quickly put all of those things together, so that way, you know, you've got you can get to your work quickly rather than fighting the application goes, oh, wait a second, you know, why didn't it compare my left eye? Oh, because it was called something else. So this takes care of that really well. Another thing that it does here is it can do oh, and here's just a menu item to kind of help you move from here to there. It's pretty simple. So this really does the same thing here. We can also do something called batch analysis, okay? And really what that is it's a way to do, instead of doing kind of one at a time, you know, because in this particular presentation, I'm doing one data set versus another, and it gives you all the metrics. But let's say you want to do a whole bunch of them. You've got a whole bunch of data sets from like a gold standard, and now you've taken your autoseg engine and you've done all the same images, but let's say it's 30 or 40 of them. And so doing it through just the straight ahead application that you see in front of you, you know, that could take some time. So what we've done here is we've created this batch engine, and basically what you do is you create a file, you create a spreadsheet. You know, you're actually not going to use the interface. It's pretty straightforward though. And let me just see if I can get you there real quick. Yeah, right. So you're gonna put together a spreadsheet, and you know, you can in the first spreadsheet you're gonna put in the path names of all of, you know, the path names of the StructSure sets, okay, that you're gonna compare against. Pretty easy to do. It only takes a few minutes. And then you load all of that into your batch analysis, and then it spits out another CSV or Excel spreadsheet, and then does all of those calculations that I just demonstrated in StructSure AI QA, but just pumps them out onto a big spreadsheet. Then from there you can create your own graphs or whatever you'd like to do. It's a way to do like a whole bunch of them at once, rather than onesie twosies all the way through. Unfortunately, there's not like a real clean interface for that yet, but again, it's a real easy thing to set up. And once you've got it set up, you just run it, and you've got, you know, plenty of data to work with. So that's the batch analysis here. Let's see. Oh, and then finally, lots of different reporting. you know, from a full report. I'm not going to click that because I've got so much data here. It'll take a little while to put together, but it's very, very rich. Another one here is like even just a quick one pager is kind of a what you see is what you get, you know, and it's very nicely done, and it gives you everything that you're seeing there. So yeah, an excellent reporting engine here for you, you know, and or of course you can export the results to a delimited text file for further analysis. So that, everybody, concludes my presentation of StructSure AI QA.